Today we are looking at chemistry alternative B questions, practicals. So this is the front page of the question. Let's deal with it. Let's go straight to question 1. So question 1 says D contain 1.58 of this in 2 cm cube of solution. E is 3.5 gram per dm cube of impure KMnO4 put into a burette. Titrate, blah blah blah. Then we are asked to calculate the average volume of E used, and then the equation of the reaction is given to us as this. So to calculate the average volume, meaning you have to titrate and get your endpoint. So based on the practical conducted, the endpoint, which is our VE, is simply 25.5. I mean to say, the endpoint VE is 25.50 cm cube. This is the endpoint. So how do we use it to prepare our table to calculate the average volume? So in this case, I will draw the titration table. Draw the titration table. We're going to have, first of all, we'll write volume of pipette used. The value is always 25.00 cm cube. That's the volume of pipettes. Most schools are used, although you can use 20. If you are using 20, you record 20.00. So I will draw my table. This is our titration table. So I'm going to have my rough, first titer, then second and third. So let's take here as our rough. There is first titer. This one is second titer. While this is third titer. Then here I have my titration. Here's titration. And here's burette reading. So we have final reading, initial reading, and volume of acid use. Here become final reading. The cm cube. We have initial reading. Also is cm cube. Then volume of E used, also in cm cube. So with that, I can now manipulate my table based on the endpoint of 25.5. So let me say I started with 50.00. Yeah, let me have 25.60. Here will give me 24.40. Okay, the rough should be higher or lower than the actual endpoint. So let's say I also started with 50.00. Here is now 25.50. So the initial now becomes 24.50. Let's also take it as 50.00, 25.50. Here is 24.50. Let me see, here's 25.50, 0.00, 25.50. So with this, we can calculate our average volume of EU. So I will have VE will be V1 plus V2 plus V3 over 3. So our VE now will give us 25.50 plus 25.50 plus 25.50 divided by 3. If you sum up, this will give us 25.5 into 3 places. That will give us 76.50. 76.50 divided by 3. So our VE will give us 25.50 centimeter cube. So this is now the average volume of the acid used. Okay, that is question 1A. Then let's go to 1B. Don't forget, look at the mole ratios. Mole ratio is 5 to 2. Don't forget that it's 5 to 2. So let's go to question B. 1B. Say from the result and information given, calculate the concentration of D in grams per dm cube. So let's go identify who is D. So our D contains 1.58 grams in 250 cm cube. So that is D. So mass of D, mass figure B, Roman figure 1 now. Mass of D is simply 1.58 gram. Dissolve in the volume required to dissolve the 1.58 is 250 centimeter cube. So we are asked to calculate the concentration in grams per dm cube, but the volume here is cm cube. I need to convert it. I know that 1 dm cube is equivalent to 1000 cm cube. Okay, so how many dm cube? We don't know. That will give us 250 cm cube, because which is the required volume. So this one now implies my x now will give me 250 times 1 dm cube divided by 1000 cm cube. So if you cancel, so 250 cm cube is equivalent to 0.25 dm cube. So with that now I can calculate the mass concentration. So mass conc of D, put in bracket, which is simply mass over volume. Mass concentration is equivalent to density, which is mass over volume, but in grams per dm cube. So the mass is 1.58 and the volume now is 0.25. So it will be the mass conc. Mass conc will be what? Let's divide that. 1.58 divided by 0.25, that will give us 6.32 grams per dm cube. This is a solution to B, Roman figure 1. Let's check B, Roman figure 2. Say concentration of D in mole per dm cube. So the same D now, but in mole per dm cube. Let's identify who D was. Our D is the potassium, is the acid, is the weak acid. So we need molar concentration. We know that, Roman figure 2 now. Molar concentration is simply mass concentration over molar mass. So let's find our molar mass. So we'll say molar mass of the acid now, which is H2C2O4.2 H2O. So how do you get our molar mass? The sum of individual atoms. I'm having 2H plus 2C plus 4O plus 2 into 2H plus O, which is the oxygen. So this will give me 2 times 1, atomic mass of hydrogen is 1, 2 times 12, carbon is 12, 4 times 16, oxygen is 16, 2 into 2 times 1 plus of 16. So if I add up, I'm having 2, 24, 64. So I'm having, implies 2 plus 24 plus 64 plus 2 into 2 plus 16. Okay, which is 2 plus 24 plus 64 plus 4 plus 32. If we add up, what are we having? 2 plus 24 plus 64 plus 4 plus 32. We're going to have 126 grams per mole. With that, I can now find my molar concentration now. Molar conc, which the mass conc we've gotten. The mass conc we've gotten is The mass conc is 6.32. So our molar conc, the molar conc now will be, molar conc of D will be 6.32 divided by 126. What are we having? So 6.32 divided by 126 going to give us a 0.050 mole per dm cube of D. This is now the solution to Roman figure 2. So let's check Roman figure 3 and see what it says. Now figure 3, we are asked to consider the constitution of E now in mole per dm cube. So we have, this is where we involve the general formula now. Roman figure 3, we are going to have general formula now. I'm going to, is the oxidizing, does it follow the normal acid base oxidizing? Does it follow neutralization pattern over reducing? Oxidizing agent over reducing agent equals to 2/5, which is the mole ratio. So I'm having CeVe over CdVd is equals to the mole ratio now, which is 2/5. What this one implies. So I'm looking for Ce now. I'm having Ce times volume now 25.00 over CD 0.05, value is all calculated, times 25.5 equals to 2/5. So if I cross multiply, I can get my CE. So my CE will be simply 0.05 times 25.50 times 2. We have 0.050 times 25.50 times 2 divided by 25 times 5. So what will be CE now? So let's see, 0.050 times 25.5 times 2 divided by 25 divided by 5. We're having 0.020 mole per dm cube of E. So that is solution to question E. Roman figure 3, let's go to Roman figure 4. Roman figure 4, so you calculate the concentration of this same E in grams per dm cube this time. So, you know, for you to find mass concentration, you must need molar mass. So I've gotten the molar concentration already. So Roman figure 4, I will have molar mass of E now, molar mass of KMnO4. So give me K plus Mn plus 4O. So what's my K is 39, my Mn is 55, plus 4 brackets 16. These are the atomic masses given from the question. So I'm having 39 plus 55 plus 64. That will give us 158 grams per mole. This is not the molar mass. So with that, I can find my mass concentration. So mass conc is equal to the molar conc now 0.020 times molar mass 158. What are we having? Times 158 times 0.02. What are we having? That will give us 3.16 grams per dm cube. So that is solution to Roman figure 4. So let's check Roman figure 5. We are asked to calculate percentage purity of E. So we need to get the mass concentration of the impure from the question. What is the mass conc of the impure? Let's check. Okay. Mass conc of the impure is 3.50. So I'm going to have Roman figure 5 percentage purity is equals to mass conc of the pure over mass conc of the impure. times 100 over 1. So what's the mass P of the comp? What calculated? 3.16. The impure 3.50 times 100 over 1. What are we having? 3.16 times 100 divided 3.5. That will give us 90.3%. So this is the whole solution to question 1. So let's move to question 2 or 3. I check. So what we have here is question 3. It says, in acid-base titration, give reasons why the burette readings are taken at high level. The high level is the meniscus point. So if you have it like this, it always forms in this shape. So you read it from the high level. This is the high level. Now, why are we doing so? 1, for accuracy and consistencies. For accuracy and consistency. Accuracy and consistency. Consistency. Another word to eliminate error. Data error. So that is the reason. Funnel is removed. If you don't remove the funnel, the droplet from the funnel may increase the volume of the acid. So to prevent increasing the volume of the acid. That's the reason. To prevent increasing the volume of the acid. If you don't remove it, the volume of the acid will increase. Then burette is raised with acid solution. Very important, you raise it with acid solution, even though you are not told. 1, to prevent diluting the acid, to prevent diluting the acid. Because when you raise the burette with water, some water content will also be present inside. All of them will not leave. So that is why we first of all you raise the acid with it. Or another reason, to prevent contamination. To prevent contamination due to particles inside, such as dust and among other things, to prevent contamination. That is the reason. The stage 3 laboratory apparatus used for standard solution. There's many. 1, we have the measuring cylinder. 2, you have beaker. There are much of them. Then 3, you have spatula. All these are there much. You can name as many as you can. So question demanded for 3. That's why I'm writing 3. Let's go to question 2. So question 2 says F is a mixture of inorganic salts and a carbohydrate. Then carry out the following exercise on F. Record your observation, identify any gas or gases involved, state the conclusion you draw from the result of each test. All test, observation, and inference must be presented in a tabular form. A, say put all F into a boiling tube and add about 10 cm cube of distilled water, stir thoroughly and filter. So our F is a mixture. Our F is a copper sulfate and starch. That is what F contains. Copper sulfate and starch. So what happens if I should put them in a 10 cm cube of distilled water? What am I going to experience? So I'm having a test, observation, then inference. So what are we going to have? So A, I will have F plus 10 cm cube distilled distilled water. Okay, so you should stir thoroughly. Stir thoroughly and filter. So if we carry out this practical, what are we going to have? We're going to see F partly dissolves with a cloudy blue solution, which is for the copper blue solution, cloudy blue filtrate. Let me say that cloudy blue filtrate and a white residue, which is the starch, a white residue. So what can I conclude? I can say F is a mixture of two sorts. F is a mixture of two sorts. So that is question A. So the B, you say test the filtrate with litmus paper. So what are we going to have? So I will have the same table. Yes, also test, observation, and inference. So I will say filtrate plus litmus paper. So what will be our observation? Turns, the filtrate turns blue litmus paper red. What does that tell us? It's only acid that has this property. So what can we conclude? Filtrate is acidic. That's the conclusion I can draw. Filtrate is acidic. Let's go to Roman figure 3. Now, say to about question B, Roman figure 1, to about 2 cm cube of filtrate and 1 spatula of zinc dust and sweat thoroughly. So B, Roman figure 1, that's what we're going to have. This is a test, observation, inference. B1 now, 2 cm cube of filtrate plus zinc dust. Okay, what are we going to have in the blue color? The blue solution of the copper sulfate. Zinc will displace copper from solution. The blue solution of copper of solution we gradually disappear due to the displacement of copper from solution. What does that mean, zinc? It means that zinc means presence, or you say presence of a reducing agent. Presence of a reducing agent. Because the osmolarity of copper will change from 2 to 0. So presence of a reducing agent. So let's go to Roman figure 3. Say 2 cm cube of filtrate plus ammonia in drops and then in excess. So I will have the same procedure. Test, observation, inference. Roman figure 2 now, B. We have 2 cm cube of filtrate plus NaH3 in drops, then in excess. What are we having? We are going to see the pale blue, which is the blue solution earlier, pale blue PPT form. Pale blue PPT will be formed when I add it in drops. So meaning copper is present. Then whatever excess, PPT dissolves. The pale blue PPT now dissolves to form a deep blue solution. So this is a confirmatory test for copper. So I will also say copper 2 plus is present. Or you can use the word confirmed. Then what else? To remove got 3, 2 cm cube of filtrate, then we're adding barium chloride followed by dilute ACl. So I have a barium got 3 now. The same table. Text, observation, inference. So I'm having filtrates, 2 cm cube of it, plus barium chloride, followed by dilute ACl. What are we seeing? A white PPT form. That's what we are going to see by adding barium chloride to the filtrate. What are the inference? We have copper sulfate 6 minus XO3, 2 minus CO3, 2 minus is present. So all these give YPPT. All these radicals give YPPT with barium chloride. So what followed by, so if PPT is insoluble. When I add ACl to it, PPT insoluble in dilute ACl. So if it's insoluble, that means it's only SO4 2 minus that is present. SO2 minus present. That is solution. All the filtrate contain SO4 2 minus, not SO3, not CO3. So let's see Roman figure. Let's see question C. Now it said put all residue into a boiling tube and add 3 cm cube of distilled water, then boil the mixture. So I will say see Roman figure 1 now. C1 test observation inference. So I'm having residue plus 3 cm cube of distilled water. What are we having? A suspension, a white suspension. A white suspension is formed. Then what happens if I warm or heat? Warm on heat. Okay? What happens if I warm on heat? Suspension dissolves. So you can say starch present. Okay? And lastly, say to the mixture, add few drops of iodine solution. So C Roman figure 2, C2. So mixture, the mixture plus iodine solution. So what I'm going to have, you have blue, black coloration, blue-black coloration form. What does that tell us? Presence of the reducing sugar is present. The sugar is present. So if you want to enjoy exciting videos such as this, subscribe to the channel, and we're going to treat many of them during NECO. NECO is coming, so stick to our channel to get more exciting video. STEMupAfrica. Thank you for watching. See you next.